So here we are back to the same page from your PDF of the trying to decide between sn1 and sn2 and the E1 and E2 mechanisms. Now you'll see this page a lot throughout the semester. Make sure you study it and know what can occur. We have the strength of the base. A strong base, strong nucleophile goes E2 or SN2. A weak base, weak nucleophile goes SN1 or E1. If we have a primary halide, it's going to have to be either one of the two mechanisms, SN2 or E2, based on do we have a good nucleophile or do we have a bad nucleophile that's a strong base. Then the tertiary halides can do an E2 elimination if we have a strong base, or it's going to be either an E1 or an SN1 with a weak base, and the difference between the two is if you have heat, it'll do the E1 elimination. Secondary halides, if the reaction has a strong base, strong nucleophile, it's going to be a 2 mechanism. If you have a weak base, weak nucleophile, with a good ionizing solvent, it's going to be a 1 mechanism, with the difference between the two being heat. Now with the secondary halides, they can do any of the 4 mechanisms, so we have to be careful what our conditions are to make sure we get the right reaction type for it. For solvents, if we have a polar protic solvent, it undergoes an SN1 mechanism, or it undergoes an 1 mechanism where we form the cation. If you have heat around, it's going to be an elimination. No heat, it'll be a substitution. Polar aprotic solvents favor the 2 mechanisms because they only solvate the cation. Examples of that are DMSO, DMF, HMPA, ether, and THF is another one that you'll see a lot throughout the semester. High temperatures favor elimination, so when we have heat, we more form the alkenes over the substitution. And some bases favor substitution over elimination, and the example is methoxide is substitution product because it is small, whereas T-butoxide gives us the elimination product because it is much bigger. Okay. And it is hard for it to get in to do the substitution because of the bulky size of all of the groups around the oxygen. So in an SN1 mechanism, we have to form the cation where the leaving group leaves, and then the nucleophile adds to that cation. Remember, the hybridization of the carbon with the leaving group is sp2 hybridized, sp3 hybridized here, and once the leaving group leaves, it's sp2 hybridized, and then in our product it becomes sp3 hybridized again. So remember, in an sp2 hybridized carbon, it is trigonal planar, and the nucleophile can add from either side of that in the trigonal planar cation. So next we have a couple of reactions, and we can predict the product for the SN1 mechanism, and the leaving group is just going to be substituted with the nucleophile, and we can draw the mechanism where the leaving group leaves, we form our cation, and then the iodide adds to that to give us our product. And the SN1 mechanism is basically always the same, in that when we have a good leaving group, the leaving group leaves, forming the cation. Now in this example, we have methanol, and so our nucleophile is all of methanol. So the methanol adds, giving us our protonated ether, and then we have to have another equivalent of methanol come in to remove the extra hydrogen to give us our product for the reaction. And all of these this step is going on in equilibrium here, where the transfer of the hydrogen from the the protonated ether here that we just formed and having the extra hydrogen on our protonated methanol. And the difference is, or the reason why it goes, is because we have a sea of methanol around. So Le Chatelier's principle tells us that the equilibrium is going to be forced to the other side of the step here, because with a bunch of methanol, it forces the reaction go towards the other side of the arrow. Now in the SN2, remember when we started with the stereocenter, we had to show what happened. In the SN1, the leaving group leaves, we form the trigonal planar cation, and the nucleophile can add from either the front side or the back side. And we have to be careful that we show all of that in the prediction of our products to make sure we get everything, all the details in there. So if we start with the stereocenter in an SN1 mechanism, we have to show both products for the reaction to show what's happening in it. So here at the bottom of the page we have the bromine is priority 1, the propyl 2, the ethyl 3, and the methyl is 4. So we know that this one is S. So when we go through, remember, the leaving group leaves, forming the planar cation. So the propyl group and the carbon of our cation is in the plane of the paper, and the methyl is going behind and the ethyl is coming out towards us. So the chlorine can add from either the right side or the left side of the cation, and when it adds from the right side, we retain the configuration, and this is still S, but when it adds from the left side, we invert the configuration, and this one is R, and we get basically a 50-50 mixture of these two because there's nothing keeping it from attacking from one side or the other. And we have to show both products in our reaction to show what forms in the reaction.